making sense of psi. So when you listen to or you look up previous presidential addresses in the PA, you find that they fit into a couple of different categories. One of the categories that keeps showing up is the president tries to make sense of the entire field, which of course is impossible, but there's been efforts like this. You see it repeatedly, both for the presidents of the Parapsychological Association and also the Society for Psychical Research in the UK. So why should I be any different? Making sense of psi. So I'm going to talk about in terms of 7 puzzle pieces that are in search of a picture. So one of the places I looked was the presidential address of the SPR in 1975. This was given by John Beloff. So again, I'm trying to make sense of the paranormal. And he opens his address with the following: "For reasons which I hope will become increasingly clear as I proceed, I see no prospect whatever of making sense of the paranormal in purely physical terms, however unorthodox." This is a theme that actually you see repeated again and again by various presidents, except that this was of 1975. And our ideas about what constitutes a physical system have radically changed, especially since 1900 to today. We're talking about a very different kind of what purely physical means. So I think John would agree with that. But the reason he said that is the same reason why a lot of mainstream scientists today won't even bother to look at the literature. And it's because as scientists we're trained in materialism. This is the prevailing worldview of the day. It assumes that physics is the basis of everything. And from that somehow emerges chemistry and then biology and psychology. And then consciousness then emerges out of all of this as an epiphenomenon. This gives rise to the notion that, oops, let's get that away, that we're zombies. Because if we start with pure physics, then all you are is your brain. And the brain's a physical object, and that's the end of the story. There's nothing else going on. That's, in a sense, like the current dogma within the neurosciences today. Oops, that's the wrong way. Okay, so what does this do when we're talking about psi? Well, psi is then denied, because it doesn't, if you are your brain, well, how can your brain get something that's separated from us in space and time? It can't. And you find scientists saying that these phenomena are impossible, and because they're impossible, they're not going to bother looking at the data because there's only 2 possibilities. It's either fraudulent or it's flawed in some serious way. So who thinks that we're zombies? Well, are zombies possible? They're not just possible, they're actual. We're all zombies. Nobody is conscious, not in the systematically mysterious way that supports such doctrines as epiphenomenalism. So says Daniel Dennett, and Daniel Dennett is kind of a spokesperson for this view, which is based very strictly in materialism. And it is not reasonable to throw away existing science. Materialism is way too effective as a general tool, as a way of understanding the nature of reality. It is extremely effective, so we can't throw it away, but psi exists. The evidence is too strong, so something is missing. So what's missing? It's that gold piece we're looking for. So we have puzzle pieces. It's the evidence and a few other things I'll mention. And we're trying to put together a picture of something with the puzzle pieces. And as we know, if it turns out that we're putting together a picture of an elephant, depending on how you look at it, you're going to get a whole bunch of different descriptions, even if you get it right. And what makes it much worse is, what if we put the puzzle together and we make a new kind of puzzle, which is much more difficult, like a Rubik's Cube? Or we could end up with a puzzle, we put the pieces together and we finally close the last one and we get this. So something that from you first glance at it and you say, that doesn't make any sense at all. Well, that may be a viable explanation. We just haven't reached it yet. So here's the first puzzle piece. It's how do we get from nothing to something? So the reason this comes about is because of the following. If you study the esoteric literature, both in the East and the West, it basically comes down to this idea. It's idealism. Consciousness is fundamental. And so consciousness is fundamental. It can be portrayed in this way, that rather than putting consciousness up there, you put it down here, and we just create a new layer of assumptions that goes underneath physics. This means that physics is emerging out of some sort of consciousness, which you can think of as awareness in a large sense. Well, how do you get from something as abstract, both abstract and intimate as awareness into the physical world? That's a problem. But from this perspective, psi now suddenly is not only accepted, it is easy to explain, because all of the phenomena we're talking about transcend physics, at least physics as we know it today in some way. So here's the problem. How do we get from consciousness into the physical world as we know it? Because one of the reasons I present it in this form is because, maybe this does work. Hello. Yeah, so if you present it in this form, it means that all of the physics textbooks are good. These are still good. We don't have to throw these away, and we don't throw those away. We don't throw any of that away. We just have a new underlying basis for it. So, but still, how do we get from consciousness and up? So we use the iceberg, which everybody uses for something. I will use it for indicating the transition between everyday matter and classical physics at the top. So the little yellow bars are things like classical mechanics, thermodynamics, and so on. And above that are our technologies, all of which arise out of all of that. But we now know that if you go just below the surface, you end up with nuclear physics and quantum mechanics and atomic physics. If you go below that, you start separating things into terms like the four forces of nature and quarks and fermions and leptons and that sort of thing, with the assumption that most physicists take, that there is some kind of super unified field at the bottom. Something is making this all emerge. This slide, by the way, is from John Hagelin, who's a physicist with the TM people. So I'm using his slide here for this idea. So when John presents this, he says that there's a parallel then between our understanding of matter and understanding of mind. So the parallel here is that at the everyday surface level, we're conscious. It's like classical physics is a refinement of our conscious everyday experience. But below that, we have preconscious, subconscious, unconscious, and a whole bunch of other states. In addition, there's a parallel with mathematics. So mathematics, you start with things like integers, fractions, irrational numbers, transcendental numbers, imaginary numbers, each time getting a little bit more abstract. And then there are, and transfinite numbers. So then there are operations that we apply to these numbers, things like algebra, linear algebra, calculus, tensors, group theory, Lie algebra, gauge theory, set theory, again, becoming more and more abstract as you go down. The reason why I show this parallel is because you could not do the mathematics. You couldn't create things like quantum field theory unless you had this extremely abstract mathematics. And so you push the current boundary of what mathematics are today, and you keep pushing it out, making it even stranger and more abstract, eventually physicists will come along and say, oh, you know, that we can use those mathematics to describe something that's below quantum field theory. So our understanding of matter is dependent on our development in mathematics. And I think that the parallel with mind is a good one then. Their everyday conscious experience is like counting numbers, but if somebody meditates for a long time, their ability to expand their conscious awareness into preconscious, subconscious, unconscious, and so on begins, that you begin to go all the way down. This still doesn't answer yet how we get from something to nothing. So you're looking out at the stars. What is happening when you have that experience? Well, so we take the reductive approach, and we look at the brain, and then we look at the neurons, and then we look at synapses, and then we look at DNA and the atomic structure and the quarks, and it turns into pure mathematics at some point. And then at the bottom is somewhere between the null set and Aleph null, which is the smallest set of infinities. So we've gone from an experience, and then we use the best methods that we have and go all the way down to somewhere between nothing and infinity, which is pretty abstract. And you can reverse this process then. If you start with nothing and infinity, well, somehow that's mathematics, it's symbolic, and that describes quarks, and so on. You go all the way up to our actual experience. So a way of describing this then is at first there was nothing, and then it exploded. And so here we are. Well, how do we do that? Well, there are a number of people working at the edge of mathematics to be able to describe how you start with a void and end up with a universe. And the one that I like the best is called laws of form. So this came out, this is called The Calculus of Distinctions, came out in 1969 by G. Spencer Brown. Calculus means basically a means of calculating, but it's about distinctions. And so this little book, it's a pretty little book, influenced major developments in mathematics and logic, humanities, philosophy, system theories, and cybernetics. It turns out that next month at Liverpool University, there is the Laws of Form 50th Anniversary Conference. So there's a relatively small group of mathematicians and logicians who are deeply into this idea of distinctions because it leads to all kinds of interesting things. So here's a picture of G. Spencer Brown when he was a younger man. As an older man, he looks much, much older, as most older people do. He was very interested in parapsychology, and in fact, he wrote an article that was published in Nature in 1953 about statistical significance and psychical research. So as he's saying in this article here that based on the evidence, it's pretty clear that something is going on that's real, but he had some questions about the use of statistics and the evaluation of the evidence, so they published it, amazingly. If you want to download the entire book, Laws of Form, you can go to the archive.org site and look for it, and you can get it in many different forms, which is appropriate for Laws of Form. So what is a calculus of distinctions? It starts with literally making a distinction. If you can imagine something like the universe, everything is simply a void. There is nothing in it at all. If you can do something as simple as making any distinction, you draw a line in it, you make one part of the void slightly brighter than the other, any distinction at all, what Spencer Brown did is said, well, let's symbolize this as a mark. So that little thing there is called a mark. And then you can use the mark to indicate things like the inside or the outside of a box. That's a distinction. And you can do this for very complicated versions. So here's a bunch of boxes, and you can make marks of that type. You also have rules, like you have two boxes, well, that's two marks. If you have a box inside a mark, you make it slightly different. Again, two marks, but in a different way. And then the rules, like if you have two marks that are the same, they're basically equal to the same one mark, and so on. Lots of different rules. You also have the difference between something inside and outside, and that leads, among other things, to recursion, so the Ouroboros. And this is a very important part of Laws of Form, because without recursion, you actually can't create a universe. So some of you may know that Vernon Neppe and Edward Close have developed this thing called the Triatic Dimensional Distinction Vortical Paradigm, which is a 9-dimensional model which is based on distinctions plus other things, in which they claim that this is a theory of everything that will include everything we know about physics and consciousness. So it's very difficult to understand what's happening in both Laws of Form and in the Neppe-Close model. But basically, when you open that book, almost the first thing you see is this. The theme of this book is that a universe comes into being when a space is severed or taken apart. So when you're poking at the universe like that, something is starting to take form. By tracing the way we represent such a severance, we can begin to reconstruct with an accuracy and coverage that appear almost uncanny the basic forms underlying linguistic, mathematical, physical, and biological sciences. And it is kind of freakish that you could do this with something as simple as the original distinction. The person who describes all this is, of course, constructed of it. Thus, we cannot escape the fact that the world we know is constructed in order to see itself. So we're familiar with things like imaginary numbers, complex numbers. You couldn't do anything about quantum mechanics or hardly anything else without imaginary numbers. But what you can find with the laws of form are things like imaginary Boolean values, which is quite odd if you think about it. Booleans are true and false. Well, there are imaginary versions of that. And negative probabilities. So, this is one of the consequences of using this kind of logic. It's a very abstract logic, but you can follow it very carefully through the book and end up with these strange things. So from nothing to something, there are people working on this. Laws of form is one method. There are other methods that people are using too. So the second puzzle piece is related here to laws of form and about strange logic. This is beyond true and false. So here's Nagarjuna, about 150 to 250 in the Common Era, who proposed in proper Buddhist fashion a four-valued logic. So he would put it as A exists, A does not exist, that's Aristotelian logic, but also A both exists and does not exist, and A neither exists nor does not exist. So it's four-valued logic. This is sometimes called metaphysical anti-realism. It's called that for reasons you'll soon see. So let's say, what does it mean to be both true and false, or neither true nor false? We consider the statement that the first pope in the 22nd century will be African. Well, this is neither true nor false if we assume that the future is indeterminate, because we don't know if that's correct or not. So it is a statement. It has a logical answer to it, which is neither true nor false. Well, what about some things being both true and false? Well, this statement is false. That's both true and false. So if you want to get a nice long article on this, you go to this Aeon site, which publishes essays. The logic of Buddhist philosophy goes beyond simple truth. So that's an article that kind of presents this whole idea about alternative logics. So Aristotle, as you well know, did not like alternative logics. For his idea was the excluded middle. There is only true and only false. And so here is Abu Ali ibn Abdallah ibn Sina, otherwise known in the West as Avicenna, the father of medieval Aristotelianism, who said, anyone who denies the law of non-contradiction, which is the excluded middle, should be beaten and burned until he admits that to be beaten is not the same as to not be beaten, and to be burned is not the same as not to be burned. So this held true for about 2,000 years. The Buddhists didn't agree with this, but nevertheless, there's a strong urging to not to exclude the middle. So this brings us to Silicon Valley. From 1992 to 2000, there's the thing called Interval Research Corporation, which was started by Paul Allen, who is the co-founder of Microsoft on the left, and on the right is David Liddell, who is the president of Interval, who was one of the originators of graphical user interfaces on the Xerox Star. Because Paul Allen was a super billionaire, they were able to attract the cream of the crop from Xerox PARC and the MIT Media Lab and Apple and Stanford and IBM. They had people from the New York Times reporting on this, and the developers of things called SuperPaint, the TCP IP protocol, Osborne 1, which was the first portable computer, Flickr, which is one of the first picture sharing websites, Grid Systems, which is all about networks, and on and on and on. There are about 150 staff and about 150 assistant staff at this place. One of the people who was there is this guy, Richard Shaup, called him Dick Shaup. He's receiving the Academy Award here, Technical Academy Award, for developing SuperPaint, which is one of the essence technological developments which provided CGI. So almost every movie today has CGI in it, and it can be traced back to software that Dick Shaup wrote. So Dick invited me to Interval to do a program there that we called the Phenome Project, and not the genome, but the phenome, with the idea that we would study the psyche. We would try to take the psyche apart in the same way that you might take a gene apart. And so there are people in this room who we would recognize their names, who were part of this program, were visitors. At the bottom is Ray Hyman, well-known skeptic of these things, but he was a consultant on the project as well. So the way that Dick described this was by introducing a fundamentally new mathematical concept of quantum states as logical disconnections, we can clearly see a whole range of other states that are neither classical nor quantum and which have never before even been imagined. This came out of his interest in laws of form. So he called it link theory. We also learned a lot about bit string physics, which is a form of describing all of nature with bits, strings of bits. So here is Pierre Noyes, who wrote that, and another one is Luke Hoffman, who's still around and still writing about this stuff. And I'm just going to read his abstract for this upcoming Laws of Form conference, and to give you a sense of the difficulty of understanding what's happening here. So it's called Topological Quantum Computing and Mariana Fermions. We will discuss how braiding and unitary transformations are related to anyons, as in the quantum Hall effect, and to Mariana Fermions in the structure of the electron in nanowires. The mathematics here is particularly enlightening in its relationships with laws of form and the inception of imaginary states. How many of you have ever heard of Mariana Fermions? Oh, excellent. The 3 physicists in the group. Oh, 4. Very nice. Okay. So for those of you who do not know what that is, it is described as an exotic quasi-particle best described as half a fermion. That may not tell you much more, except it has the word exotic and quasi in it. That says something. So that's like the leading edge of physics today are things that are not quite particles. And so here's Luke Hoffman talking about laws of form as a way of deriving these strange properties of these fermions. So this makes your brain hurt. If you're a physicist and you're on the leading edge of this, you can kind of figure out what's going on here. For everyone else, this level of depth of mathematical logic is very difficult to grasp. On the other hand, we're dealing with psi, which is extremely slippery and transcends space and time in some way, may require modes of explanation that are very, very difficult to grasp. And this shouldn't be too surprising because, after all, in our everyday life, we don't run into quarks. And yet, there's good reason to believe there's something like quarks out there that is developed mathematically. And we can almost see them, I think, within the Large Hadron Collider. What we see there is consistent with what we know about quarks. So we may need very strange forms of mathematics. And so here's Dick Schaup and another colleague named Tom Etter. And they spent hours, we spent hours a week at interval for an entire year discussing link theory and laws of form and these kinds of logic. And my brain was hurting. After like a week of this, my brain was hurting. So you can imagine after a year. And so I finally said to Dick and Tom, come up with something that I can test. I'm an empiricist. I don't know how to mathematically think in these forms. So they said, okay, we'll come up with this experiment. So can causal influence propagate backwards in time? So this is the way it works. So this is a standard PK experiment. You have a subject, you have a random number generator. The subject is going to interact with the random number generator and hope to get some kind of an output. That's simple. So the output in this case is if you press the button to start the generator produces a 0 or a 1. If you produces a 1, well, then we're very happy and you get some kind of musical tone or a nice audio thing. It's a little cookie that you get. And if you press it and it gives a 0, you get nothing. So you're motivated when you do multiple trials to press it and get some kind of interesting little audio file. So the outcome is very simple. The hit rate is the number of ones divided by the number of trials. Well, what if you used a more complex random generator? So we'll take a whole string of generators and we'll just put it inside a box and call it a complex random number generator. The experiment is still exactly the same, but now we're going to look inside this complex generator. And this is where the laws of form start coming out. So we start with a random generator that is a pure 50-50 choice. So it produces ones and zeros equally. And we'll call those a 1 and 0 state. So you'll end up in a 1 state or 0 state. The next stage, if you were in a 1 state, you remain there 80% of the time, and you will switch states 20% of the time. And it's completely symmetric, so it's not going to bias the output in one way or the other. It's just now adding an interesting logical dependency. And you do this again, and now the result of the experiment is the last stage, number of ones in stage 3 divided by the total number of trials. And since these are in sequence, you press a button as a subject, and you make all of these random decisions in a row. You don't know that because you don't know what's inside the magic box. All you know is it ends up as a 1 or a 0. So the task is exactly the same, except you have a much more complicated random generator. So this thing in the bottom is called a Markov chain. It's a way of representing how things progress in time in a probabilistic way. So here's the result of an experiment that we ran at interval. So stage 1, if you remember, is the very first random decision. Should be 50-50, and if you look cumulatively over a course of 100 trials, sure enough, by the time you get to the end of the 100 trials, it's basically right at 50-50. So you're not getting anything at stage 1, but stage 2 is up a little, and stage 3 is not only up a little, it's up a lot. In fact, if you turn this hit rate into odds against chance, it looks like this. So stage 1 is not significant at all. Stage 2, maybe a little bit, but ends up being odds of 10 to 1. But stage 3, at times, it starts approaching 10,000 to 1 or even 100,000 to 1 odds against chance, and ends up almost 1,000 to 1. So somehow we did this experiment with this strange black box, got a significant result, which would say that we've influenced the random generator, something like that. And now we can do something interesting. So we're interested primarily in stage 3. How did stage 3 end up there, given that at stage 1 and stage 2 we had basically nothing? So we can ask the question, what bias would be required on a random generator at stage 1 to bias the Markov chain to reproduce the results that we see at stage 3, assuming a forward causal influence, in other words, vanilla PK. So we're assuming that somehow we're magically doing something to the random system and forcing it to produce the result that we ended up with. So visually we're doing that. We take the Markov chain, we do something to it at this stage to produce that result. What's necessary? If you do go through that exercise, it turns out that at stage 1 you need to bias the random generator from between 75 to 95% going towards 1 and 5 to 25% going towards 0. So in other words, you need to have a very strong change at stage 1. So what do the curves look like with that? The nice thing about a Markov chain is that time is independent. You can go forward through it, you can just as well go backwards. So we'll go backwards. So here's the forward bias calculation. If we change at the first random decision so that we end up with this black curve, that's stage 3, that black curve is exactly the same. I'll put it here. You end up at 56%. That is the same 56% here, and the two curves actually look identical. They're on different scales, so they don't look identical, but they're the same scale. Well, what happens at stage 2 and stage 1 in order for that to happen? As you see, stage 1 now, you end up needing almost 100% ones at some point, around trial 26. And even at the end, you still need to end up with about 70% hit rate. But we know that that didn't happen. What really happened is on the right side. You didn't see that at all, so the cat is unhappy. So what we know is that what we see in this experiment is not to vanilla form PK pushing in the future. That doesn't describe the results of this experiment. So we can say, what constant bias would be required to bias the Markov chain to produce the observed stage 3 end result, assuming a forward causal influence? So again, PK now changing everything in the random system. Well, you can do that calculation, and that's a 3% bias on every stage along the way, but the two curves still don't look anything like it. So that's not what happened either. So we ask, what if we run stage 3 results backwards through the Markov chain? At every stage along stage 3, we simply run it backwards. And what do we get? So there's the actual results. There's stage 3, 1 backwards. It's starting to look very close to what we actually got. And if you run it backwards with a minus 3% bias, you get almost exactly what we ended up with. What this tells us, and now we have a happy kitty. What it tells us is that psi in this experiment appears to select an optimal path to achieve a final goal. In this case, it means that the goal might entail going backwards in time. So this is a way of demonstrating retrocausation because we have a way of tracing, almost like a bubble chamber, where you would trace particles in physics. We can trace how did we get there, and when you do that, you find out it's much easier to explain these results by having the results start at the end and ripple backwards in time. That's a retrocausal effect. So we published this in 2006, and we've also done a number of other experiments which we haven't published. So this is one of them. We have a 100-stage Markov chain. So it's exactly the same as before, except now it makes 100 decisions in a row, and you get your results at the very last stage. And we also, every trial, we blindly define success either at what the result is at stage 30 or 60 or 100. And since you don't know, all you know as a subject is you get a nice tone at the end or you get nothing. Well, so what happened in this experiment? There's the results. So at stage 30, you get almost a 3 sigma rise in the results, which is pretty good. At 60, you get a minus 2.8 result, and at 100, a minus 1.5. So this is not what we would like. We'd like all 3 of these to be significantly positive, but that's not what we end up. Nevertheless, if we take a chi-square approach to say, are the deviations expected? The answer is absolutely not. We're dealing with some kind of weird effect here, which may be described possibly as an interference effect. Because in this experiment, we're changing where the important part is to be influenced, and maybe by switching them randomly, they were interfering with each other, and that's why we're ending up with both positive and negative results. We don't know. But we did many, many more experiments like this, and you start to see patterns that begin to show up that suggest, again, that somehow it's the end result of these kinds of experiments that's important, and then everything just ripples backwards in time in order to make it come out the way you want. So this is about strange logic. So there we have some. So third point, brain morphology and genetics. This, I think, may be the golden piece, because it will give us a kind of leverage that we haven't had before. So the first one is this thing, Effects of Frontal Lobe Lesions on Intentionality and Random Physical Phenomena by Maurice Friedman, who's a neurologist at the University of Toronto. What he has found in brain damage patients who have frontal lobe brain damage, that they were able to repeatedly get successful results in random number generator studies. Suggesting that the idea of a filter hypothesis may be correct, that if you destroy the portion of the frontal lobes, which are the filter, which prevent us from being able to see the world the way it is, well, then you get really good psi. So nobody's volunteering to have brain damage, but at least one person in the audience is seeing whether transcranial magnetic stimulation can momentarily inhibit the frontal lobes and create the equivalent of a virtual lesion, and then have people do experiments, and as I understand, it didn't work. So maybe it needs to be more refined or get exactly the right spot. We don't know yet. But it's a clue. So he's pursuing this line of research. The other thing is this. So this is an MRI of a normal brain. And the important part to look at is there, which is the caudate, which is an ancient structure of the brain near the basal ganglia. It's an old part of the brain. It's the section between the caudate and a section called the putamen. So if you have brain damage here, you will end up looking like you have Parkinson's or schizophrenia or a variety of other not so good things. So that's a normal brain. This brain is the same spot. It doesn't look normal at all. In fact, the number of fibers here is 5 to 10 times more than in a normal brain, and the connectivity is much, much stronger. And it's bilateral, so it's on both sides of the head. It is not a lesion because it's found in families, suggesting a genetic basis. And more importantly, these MRIs come from looking at people who report exceptional experiences, including psi experiences, and some of the military remote viewers have the same structure. So there's reason to believe that not only are people reporting hallucinatory things, perhaps, but verified talented remote viewers also have this thing going on. The other thing is that people who have this particular lesion have been checked both in terms of performance and psychology and medical workups and psychiatric workups to find, are they nuts? And the answer is no. They appear to be normal in every way, except that they occasionally will see a glowing orb come through the wall and speaking to them telepathically. So that's the reason why these were found in the first place. That people in positions of high responsibility, like people who work in nuclear missile silos, would occasionally report things like this. Oh, last night I saw the fairy come through the wall again. And they will report this on their bi-monthly review, and the psychiatrist would get alarmed, and they take an MRI, send it off to a forensic psychiatrist who began to see these things. Sometimes the person is nuts, except that these people aren't. So you want people who are in positions of responsibility with their finger on the nuclear button to not be nuts, and that's why this basically bubbled up to the top, because they needed to make sure that even somebody who had this and was talking to fairies is stable enough to be trusted with a nuclear weapon. So this suggests both a genetic basis and a brain morphological basis. The backstory on this is even more interesting. In the 1960s, a psychiatrist was interviewing a psychic. This happened to be a channeler who was also a clinical psychologist. And part of the channeling session, the psychic says that in the future, this was 1960s, remember? In the future, the scientists will find that the caudate in the brain is the antenna of higher sense perception. This is before MRIs were regularly used, and so while we knew that there was a structure called the caudate, we had no idea what it did. So it's interesting that roughly 40 to 50 years before we were able to get pictures like this, a channeled psychic was already talking about the caudate. So if you want to learn more about this particular thing, you go to YouTube and you look up the DNA of the strange, with special guest Dr. Gary Nolan. So Gary Nolan is a genetics professor at Stanford who's involved in this project. So none of this is secret, but the way that they're talking about it is it's very preliminary, which it is. There are not that many cases involved, but there actually may be a morphological difference in the brain. That in the Stargate program, they tried very hard for years to find anything different about Joe McMonagle, for example, a really good remote viewer, and anybody else, and they were not able to find anything. Well, that's because the technologies of this type were not available. The other technology wasn't available, it was this. So we didn't have a way to do a full genome sequencing, but now we do. So funded by the Be-All Foundation, we started with 3,500 candidates. We pulled them down to 27 finalists. These are people who passed multiple hoops to make sure that they were psychic, from psychic families, and vetted to be actually psychic, and then matched against controls that were not psychic and not from psychic families and did not do anything in a psychic test. We got their DNA, we ran their full genomes, we compared the psychic cases and the non-psychic controls, and we found genetic differences. The bioinformatics person who did this was extremely surprised because we expected that we'd have to do these genome-wide network analyses to look at maybe constellations of hundreds of genes or even more in order to find any difference at all between this contrast, psychic and not psychic, but we actually found a half a dozen genes that popped out right away. And none of them were found in the control group. So this again suggests that there's either a genetic basis, and especially for the folklore that psychic ability runs in families, we're finding, yeah, it looks like that is the case. So brain morphology and genetics give another piece of the puzzle. Number 4, replication non-crisis. So you find articles like this: psychology's replication crisis is running out of excuses. That another big project has found that only half of studies can be repeated, and this time the usual explanations fail. So the article says, ironically enough, it seems that one of the most reliable findings in psychology is that only half of psychological studies can be successfully repeated. Does this sound familiar? These are the reasons given for why you can't replicate conventional psychological reasons. The first is people were sloppy, or they're incompetent. The practices were sloppy, or the people were incompetent, small effect sizes, insufficient power, reporting flukes as significant, p-hacking, file drawer effect, experimenter differences, or subject differences. So we've heard these criticisms a million times. In fact, we know about these in PsyResearch as well. They're exactly the same as they are in conventional psychology. PsyResearch has been forced to pay attention to these because we knew we had a replication problem for at least 50 years. So here's one reason for declining interest, and this is in conventional psychology and interpersonal factors. There's one reason. So ironically here, this is about interpersonal factors, except not directly anymore. It's through digital media, which is a very impoverished form of interaction as compared to the way we've been evolved. And this is not just a problem in psychology. Here's an example of Harry Collins, a sociologist, who did a study of the first attempts to build a transversely excited atmospheric pressure CO2 laser, otherwise known as a T laser. So the lessons he learned was that no one succeeded in building this laser by only using information found in publications. Second is that no one succeeded in building a laser where the informant had not personally built a device. In other words, if you talk to somebody who had read something, or maybe even was present when somebody built it, you still couldn't build a T-laser. Everyone who is successful attained crucial components of knowledge from personal contact and discussion with somebody who actually built the laser. And the success of building it was doubtful without extended contact with the informant, and even that wasn't always sufficient. So we see this in PsyResearch all the time. Probably the best known case is the Schlitz-Weisman studies, and Caroline did a very nice interview of Marilyn and Richard to show the difference in terms of the interpersonal reactions. So when Marilyn started to do a staring study, subject would come in, and the way she would describe it is like this. She would get centered before doing the task. She would pray, she would focus, she would prepare, she'd customize for the individual. She would engage the person to create rapport. She would positively prime them and use words like divine grace and even magic in describing her preparation. Richard, by comparison, had no preparation, no customization, a very business-like attitude, no engagement with the subjects, no priming, no rapport, and during the staring period, he just looked at the screen. So from a sociological perspective, you look at this and say, well, they've got to get differences in these kinds of interactions, because in a sociological experiment, you get massive differences. Even in parapsychology, you get differences. So Jewel Eisenbud wrote this as kind of a summary of one of the problems we face. Psi experiments are conducted assuming that subjects won't use psi until they step into the lab and hear the starting bell. And then, only within the confines of the roles that they've been given, the experimenters will not use psi that they may have, and everyone will agree to stick to the assigned roles and take no notice of what anybody else is doing. That's kind of the way that we run these experiments. And you can see immediately why this doesn't work so good. So the replication non-crisis, I would say, at least as far as parapsychology is concerned, we know it's not actually a crisis because our meta-analyses tell us that it's not a crisis. In any given experiment, it's really tricky, but when you look at them in total, you find interesting results. So now quantum weirdness, my fifth piece. So we know one of the major things about classical to quantum differences. The classical world is thought of as being local, causal, and reality observer independent. That's like everyday common sense. And the quantum world is almost exactly different. It's non-local, it's acausal, and it seems to be observer dependent in terms of reality. So we're talking about a parallel between psi and quantum mechanics. It's not popular to talk about the two in the same breath, especially if you're among conventional physicists, because they're saying you use the weirdness of one to explain the weirdness of the other, and that's illegitimate. And I would say, I don't think so, because we're talking about the same kinds of weirdnesses in both cases. Psi is non-local, acausal, and observer-dependent in terms of our sense of what reality is, and exactly the same thing is true with quantum mechanics. I don't think that's a coincidence. This doesn't mean that quantum mechanics explains psi. That's like my pointing and mistaking my hand for where I'm pointing. I'm pointing towards quantum mechanics as explaining a kind of reality that we live in, which is completely compatible with the experiences that we talk about. But quantum mechanics in its current state is not sufficient to describe everything about psi. It's just pointing in the direction. As compared, by the way, to classical physics, there is no pointing, because classical physics, basically psi is impossible. You also find now there's a quantum experiment suggesting there's no such thing as objective reality, because observers can look at the same thing and end up with different results. This is a paper that came out in February, Experimental Rejection of Observer Independence in the Quantum World, which in essence is saying that what Wigner and Wigner's friend observe is not necessarily the same thing. So two people are looking at the same thing and actually seeing different things. I think you'll learn a little bit about Wigner's friend if you don't know about that tomorrow, in tomorrow's session. Here's another one, prediction and retrodiction for a continuously monitored superconducting qubit. In Physical Reviews, came out in 2015. This is basically saying that the idea of retrocausation in a quantum system is pretty well understood and could be demonstrated in a variety of ways. So retrocausal effects, as I was describing in our experiment, is okay in the quantum world, not so much in the physical world. So they say that in this case, our experiment confirms Bohr's view that it does not make sense to ascribe the wave or particle behavior to a massive particle before the measurement takes place. In other words, the future is influencing the present. So that's quantum weirdness. Well, there's more quantum weirdness. So it's about quantum biology. So this, up until maybe 10 years ago, is considered to be almost laughable, that you couldn't sustain quantum coherence in the wet, warm brain. That is beginning to change as we're finding more and more areas where quantum mechanics might be necessary in order to see living systems the way they work. So this one has to do with the rate of catalytic effects in proteins. This one is the speed of a proposed way that photosynthesis works, which involves testing all paths at once rather than jumping one to the next. And this one is about magnetoreception in birds, looking at cryptochrome as a quantum-sensitive protein. So more quantum weirdness. And the last piece I'll call Indra's net. So there's Indra's net, basically what it says is psi is consistent with the idea of an interconnected web of relationships, interactions, and influences that transcend space and time, just like the myth of Indra's net. Given this, it's a major miracle that we see any evidence for psi at all. When you think about it, both given what Jewel Eisenbud was saying and about this incredibly tight interconnection through space and time, that whenever you do a psi experiment, any experiment, you are attempting to carve up the universe into a little isolated piece. But all of the evidence says you can't do that. That's not the way that the universe is. And even with those constraints, we still end up with, certainly with meta-analytic evidence for psi. So somehow what we're dealing with is probably extremely robust. It may be far more robust than we've ever imagined. We just need clever ways of finding it. So maybe we're too myopic in the way we think about psi. We're kind of forced to when we ever do an experiment. You're creating this little bubble and looking at it in great detail, but maybe missing something in the process. So there's this weird recursion that goes on all the time, and maybe we can think about it in more detail. Perhaps not in the form of The Simpsons, but why not? So there's Indra's net. So here's our 7 puzzle pieces, and there are many more I could have mentioned, but you would all fall asleep by then. So what do we see when we put these puzzle pieces together? What is the picture that's being presented? Well, here it is. And the caption says, "It was bad enough for Sisyphus before the gods added a circus poodle." So I think we're attempting to find a picture. We don't know what the picture of the universe is yet. It is very like Sisyphus. We keep pushing, we're pushing the same thing, and we get to the top and say, we finally got it, and then it rolls down again. And occasionally the gods will put a dancing poodle on top of the rock that we're pushing. So in conclusion, when I heard the learned parapsychologist, when the proofs, the figures were ranged in columns before me, when I was shown the charts and diagrams to add, divide, and measure them, when I, sitting, heard the psi researcher where he lectured with much applause in the lecture room, how soon, unaccountable, I became tired and sick, till rising and gliding out, I wandered off by myself in the mystical, moist night air, and from time to time, looked up in perfect silence at the stars. Of course, this is really from Walt Whitman, not me. And I thank you for your kind attention.